Welcome. Triggr is a lightweight code-based monitoring tool. It works like a sensor network. Sensors, or in Triggr talk, probes can locally be attached to a code fragment and monitored centrally. So Triggr can be configured in a distributed fashion to meet individual monitoring needs of engineers working on the same code base. Let's see how this works. Triggr's source code has two example probes, one for static analysis and one for code changes. We will copy the static analysis probe to define a new probe like it in an existing local repo called Recit. Recit is the repo that we wish to monitor. Now we will add a Triggr folder to our repo. This will contain the JSON files for the probes. We are defining a new probe in this folder by cloning the one we just copied. It's called copy file static analysis. This probe is defined to run static analysis on copy file sync function at every commit. The probe has an actuator that uses the email channel. The actuator will send an email to the specified engineer when the probe activates. We fixed the name, path, and type of the object to which the probe is attached. It's the function copy file sync in the utils.js file. We want the actuator to send an email to the specified engineer. But only when the cyclomatic complexity of the object exceeds 2. Let's add another probe, this time to monitor any changes to a function called createApp. Again, to save time, we clone it from the Triggr source code and change it. It's attached to a function createApp in file createapp.js. To define this object in the probe, we change the object name and path. Then we specify the same email channel in the actuator as before. We have added two probes. Let's commit them locally first. Now let's push these additions, the two new probes, to the central repo. By pushing the probes to the central repo, we have effectively added them to the code base. Now we need to tell Triggr to monitor the repo. To ask Triggr to monitor our repo, we need to add its URL to Triggr. A user-generated token is also needed for the repo's webhook. We are ready. Now Triggr is monitoring any changes to the repo Recit. And when a change happens, it will check the probes and activate them if necessary. To see how this works, let's first locally change the createApp function and then push the change to the repo. We edit the createApp function. Remember, a code change probe is attached to it. We commit and push the change. This causes the central repo to call back Triggr via the webhook. We can check Triggr's job dashboard to see what's going on. Triggr is executing the probes. Probe execution completed. Let's check the console output. we see that the code change probe was activated in green. And it says in red that the create app object was changed. The probe should have also fired an email actuator. Let's check. Yep, the email has just arrived informing the engineer of the change. To trigger the other probe, we now locally edit the copy sync file function. It's in file util.js. We edit the function so that its cyclomatic complexity changes. And let's commit and push this change to the central repo. After the push, Triggr re-executes the probes. This time, the static analysis probe should be activated. Let's make sure. There, in green, we see that it was activated and an email actuator was fired. We check the engineer's email reader and see that the notification for the change in complexity was delivered. This concludes our demo. Thank you for watching.